Assalamualaikum and greetings. I am Kamil Khalili from the Mechanical Subteam. The body of the STEM set SL1 was designed to be 3D printed using PLA plastic. The cover consists of 30 different slits to allow air to circulate between the atmosphere and the instrumentation so that the sensor could get better readings. The PLA plastic will be supported by carbon steel rod as the tensile strength of carbon steel is 10 times higher of PLA plastic to ensure that the STEM set SL1 could finish the mission without suffering any damages. The payload will be held together by the clamping force between the 3D printed parts so they will stay in place while will be easily accessible when they. The wave-share sensor is the backbone of the mission. It consists of 4 different sensors that could obtain readings for 6 different types of data. These sensors are enough to collect all the data required to fulfill the primary mission data collection requirements. The sensor speaks to the Raspberry Pi through I2C connection, which allow 128 different sensors to communicate at the same time using only 2 wires. This simplifies the connection between the sensors to the Raspberry Pi as fewer wires are needed to connect to them. The SenSat sensors were put to the test when it was left to collect data for 24 hours. This gave the team a better understanding of how to use the SenSat and its overall performance.
Hi, my name is Amir Hamza from UMP MySTEM. I am a member of mechanical team and I am in charge of producing the recovery system. So this is the parachute. It is made from a restored nylon material. It is pre-made with a diameter of 2 meter. However, our calculation require a diameter of 1.09 meter. So we need to cut it and reseal the side. This is mean after we cutting the parachute, it will look bad. So we need to seal it again to maintain the shape. This is the nylon thread that will be need to attach the parachute to the stem set, and this will be attached to the stem set using hook.
Hello, my name is Paulson Yu from team UMP MySTEM. I'm part of the electronics team and I'll be showing you the STEM-SAT transmission system. On the left side, we have the Raspberry Pi 0W. There's Neo 6M GPS and the 433 MHz transceiver. On the right side, we have the ground station. We have a similar 433 MHz transceiver connected to a generic Arduino Uno, and this is used to interface to the laptop. The Raspberry Pi is reading the GPS coordinates from the Neo 6M GPS and transmits it through its 433 MHz transceiver to the 433 MHz transceiver on the ground station, and this will then be sent to the laptop. On the Arduino IDE, we can see that the GPS location coordinates is being transmitted from the STEM-SAT to the ground station. Using the coordinates given by the STEM-SAT and Google Maps, we can tell exactly where we are. Here.
Hi, my name is Yusuf, member of the electronics team. The first thing I want to show you is preview on reading data from PM2.5 sensor by using the Arduino. This is as a preview because the real project the data will be read by the Raspberry Pi. Next is I want to show you the different readings and the different conditions. The first condition is during raining. Okay, the result we get is about 10 micrograms per cubic meter. The second condition is get by the data of air released by the motorcycle which is CO2 or carbon dioxide. The reading is less because the reading was taken for a few seconds and the concentration of air was not concentrated, and we can see less smoke is produced. And the third condition is fire smoke or haze. As we know, in 2019 is the year where haze and air pollutants one of the biggest disasters that we had. And this is the simulation of PM2.5 such the particle from the smoke. Okay, as you can see, the readings can up to 800 micrograms and higher, about 1000 micrograms per cubic meter, where it is very dangerous for human lungs. And for the UPS power, the product could be used to supply stable power for some applications requiring mobility such as Raspberry Pi camera, tablet PC, or field data collection system.
Okay, so what we have here is the Raspberry Pi Zero W. It's a small single board computer developed by the Raspberry Pi Foundation, and it used as the onboard computer for STEMSAT SL1. This Raspberry Pi using the VCM2835 SoC processor with 1 GHz clock speed, and also it includes 512 MB of RAM. This chip here is provided for the Wi-Fi and Bluetooth connection. And this Raspberry Pi Zero use micro SD card to hold the operating system, and the onboard storage it connects the two other onboard instrumentation through its 40 GPIO pin. Overall, it collects data from onboard sensor, then process, store, and transmit them to the ground station.
Today, I will simulate a graph using the telemetry viewer 0.6. First, we test, then connect. Okay, then so we try to add up the columns into 12. Okay, then we pick two columns each. So we waveform A and we use it seconds, 10. So we can see the graph is voltage against the time. So and then we add another two column waveform B seconds. So we choose 10, then so try it with waveform C seconds, and then so we try to combine it with the three graph. So waveform A, waveform B, waveform C, then seconds, 10. So we can see the graph is the same, the voltage against time. So we can see the voltage up, down.
Hi, my name is Natalie Christopher. My team name is UMP MySTEM. I'm from the software team and I am in charge of the flight software. This is a demonstration of the Eclipse IDE which will be used to program the flight software of the STEMSAT. So, here I have created a simple program that will show the current time and date, and a program that will randomly pick a number between -10 to 10 and state whether it is a positive or negative integer. So I will run the program. Okay, as we can see here, this is what it will execute. It will print the current time and date, and it would also randomly pick a number and will state the number whether it is a positive integer or negative. That is all for now. Thank you.